Guys, is my video visible?
Yeah,
Yes,
Nachiket,
it all.
it's there.
No love, your video is not visible at the
Why
moment.
is it not letting me open?
Nachiket, full screen, please.
Guys, it's not audible.
It is. The video is not audible.
Yes, yes, it's not audible. And taskbar is visible. Nachiket, make it full screen, please. And, it's 7, guys.
Hi, Jerry. Can you hear me?
Yes, I can. Yes, Praveen.
Thank you so much, everyone. Okay, thank you so much everyone for joining in. So may I please request Jerry Ma to start off the webinar? Move the slide.
Great. Sounds good. So if we can go to the first slide. Welcome everyone to, thanks for joining the webinar for using AI to deter terrorism detection and discrimination. Thanks for joining, and my name is Jerry Ma, and I'm currently a pre-sales analyst here at Zummit InfoLabs. And I do tasks related to AI, machine learning, and I'm currently situated in Canada. And I deal with a lot of project proposals, client calls, and just all that. Today we also have with me Praveen Kumar, who is the co-founder and practice head at Zummit, and also Deshpande, who is the director and technology here at Zummit. So let's take a little peek at what we're going to present here today. And I'm currently situated in Canada, and I deal with a lot of project proposals. Could be, yeah. Great. So this webinar looks like an interesting topic in which it tries to address. Essentially, it is the problem of using technology to aim towards a safer and more equitable world. Essentially, the problem originates from the fact that humans interact and communicate with people from different geographies, regions, and backgrounds. Our world is technologically advancing, and AI, machine learning, deep learning can all be used to deal with this intrinsic problem. Now, this is where we talk about our solutions. And in the next few slides, we will explore how we can implement solutions to recurring problems that Zummit provides. So what is the big problem that we are all facing today? Well, as you can see on the slide right here, the September 11 attacks in the US, the London blast and 26/11 attacks in Mumbai are all reminders of the threat to the safety of the living environments around us. Discrimination against gender, race, color, age are all reminders of how much we need to progress as humans to make the world a better place. Now, there have been some known and more unknown incidents about discriminations toward customers in the hospitality industry. While they are not as known, they are equally as intrinsic and crucial to our society. We hear about these discrimination towards certain ethnic groups, about being treated differently by the staff as opposed to others. Contrasting behavior with people of different color and origin compared to certain customers, and how and many more other examples such like that. Right off the top of my head, I can just think of a problem that, for example, a few years ago in United Airlines, there was a passenger that was dragged off the airplane. That is just pure discrimination. That is very bad to our society. So how do we address this issue and terrorism and discrimination specifically? Now, if we can go on to the next slide. Here you can see that there is a need to implement technology in order to combat terrorism and behaviors. So how do we combat terrorism and discrimination? What are some ways we can prepare ourselves against terrorism and discrimination? Well, as you can see on the screen, you can read for yourself, but I'll kind of go over a little bit about what each of them is about. These include things like identifying specific suspicious objects in public places, figuring out a mechanism to detect unattended bags swiftly, coming up with a solution to identify known terrorists and people from the wanted list, walking freely in public spaces, and essentially also detecting body language, nervousness, and behaviors in places like airports. Some are already implemented, like using a CCTV to monitor people or scanning objects in bags. Then again, there are a lot more other solutions. So how does this all apply to our daily lives? Well, you see, as we move on towards a more technologically advanced society, we can ultimately start seeing that tech is getting better. Technology is improving at an exponential rate, and they all help us achieve things like solving racism and discriminations. You can see analytics, cloud, big data, digital, social media, AR and VR, RPA. These are all roles of technologies that play in our daily life today. And They're just help us achieve things like solving racism and discrimination. There's a lot of RPA, deep learning, big data. So if you can go on to the next slide, what we get from this ultimately is that we now have smarter gadgets, and ultimately there are more opportunities now for us humans to experiment with terrorism detection, discrimination, and there's just more opportunities for us to do. And this is just a list right now, but as you can see on the slides, we will look at some more important roles of AI and ML. So we have computer vision, which is very useful, and people have actually been caught using this. And this basically focuses on identity of people's faces, which we will talk about a lot in the next few slides. NIP is also very crucial. It can detect certain keywords, and online terrorism is on the rise. So NLP can actually help this issue a lot better, and it can ultimately fight it. Now, I'm just talking a little bit about them, emotion detection, anomaly detection, anomalous behavior, object detection, very crucial as well. You can detect real objects, suspicious items, dangerous items. These are all very important. And now we will take a deeper look into the area, starting with computer vision, followed by object detection and more. So now I will hand it on to Mr. Praveen Kumar to have a more detailed explanation of these. And he is the co-founder of Zummit InfoLabs and practice head for data science. Praveen actually has 23 years of experience in the industry implementing solutions at organizations such as RBC, the Toronto Stock Exchange, Monster.com, Verizon, and even more. So Praveen is a very experienced man. Now I will pass it on to Praveen, and he will talk about the approach, and many more.
Yeah, Jerry, thank you so much. Thanks for the introduction. A very nice introduction into the problem statement itself, how technology can be used for racism and terrorism detection. There's been a lot on the rise. Those were something which was very insightful. I'm going to talk about various approaches that we can take to curb terrorism. There's many more too, but some of these I'm going to talk is all very important ones that everybody should start implementing. We're talking about public places like airports and other religious places or many other places, right? So how do we attack this problem, or how do we approach to curb terrorism, discrimination, everything? So let's look at terrorism as the first step, right? The first item on the list is to look at face recognition, and then there is object detection. We are sorry. Could you please go back to the previous slide? So there's face recognition, and there's object detection. There's emotion detection by thermal signatures, anomalous behaviors of people that we need to look at, and then there are situations where there are bombs in the unattended baggages. I'm going to look at each of these and talk about it a little more in detail. But also one very important thing it's a very good input for all of us designing deep learning solutions for terrorism detection could be the book written by Lillian Glass and also the FBI Special Agent Sullivan, who have, based on their experience and historical analysis, have come up with really good suggestions on how visual cues, characteristics, and behaviors of people can be used to identify very quickly, right? There are a lot of dangerous people amongst us. Sometimes it could be a neighbor. You don't know, who's around and how it is. But by using visual tells, you could actually approach for this problem. And AI is in the right space where it could really, really help applying deep learning and models and all. Let's look at face recognition in the coming up item, which talks about how we address one of the issues against terrorism. Right? So, for example, NATO has this wanted list. Counter-terrorist units have all these people that they're tracking, who are potentially very dangerous, who've been historically tagged for being responsible for various blasts, explosions, killings, and many other things, right? So we know these people are already there, they are in the wanted list, but they could be walking around disguised, or they could be walking around with a clean-shaven haircut. If you look at the person in the airport, one of the terrorists has actually changed a little bit of appearance. It could fool the humans a little bit. And also, if there is a security person looking at CCTV cameras, looking at 50, 100, 200 people, how could you actually identify a person there, right? But then that's where AI comes into the rescue, right? AI module can just look at the whole screen, look at all the people, and can start finding a possible match. You could see that there's a 67% suspect match in one of the images. That's something that can give a very quick tip on people who are walking freely around us, right? And then there could be places which are not authorized for people to be going into, and if some other unauthorized people tries to access that, the program can immediately look for a stranger and then raise a flag. The security people can take actions around it. So that is a bit about facial recognition, right? So we will also look at the next item on the list, that is object detection. How object detection can be a very important aspect in curbing terrorism or any kind of threats to society. So first of all, how does terrorism even happen, right? By bringing in bombs or guns, hostage situations, blasts, explosions. All this happens because objects and items are getting sneaked in. So it could be inside the bags, it could be on the person, it could be also from the body. Somebody would remove the a gun into a public place and could start a hostage situation or could be a threat to people. So object detection gets very interesting here, wherein a lot of flagged items or suspicious items can be trained by using AI, by using deep learning models and techniques. We could train the program to identify various objects like a gun or a knife or any other harmful object immediately. So now there are these metal detectors, but how can a metal detector probably look at a ceramic gun? Now ceramic guns are different material, it will not get detected by a metal detector. So what happens in a situation where somebody has somehow with some influence or other means sneaked in a gun and in a public place opening up a firearm? Imagine a human, a person who's looking at 20 different screens or sub-grid screens onto the monitors, trying to look at what's happening in different places, right? And think about a program which is trained to identify objects, can start looking at the moment the person starts pulling out a gun, immediately the program is able to detect real time, live, that it spots a gun and it says something's danger. And just that reaction time of a few seconds could even save a person's life or save a hostage situation or give enough time for the security personnel to jump in and take care of the situation. So that's one of the very important aspects using object detection. So we will also now look at emotion detection in our next slide, where how so emotion detection itself is one of the very important aspect of emotion of the terrorism and even in discrimination, of course. People could be monitored for normal or abnormal behaviors. Abnormal behaviors could be nervousness. Somebody is up to something, suspicious activity, and they're probably nervous. That can be detected by a camera trained program. Right? Eyeball tracking, if a person is fidgeting, nervous, body language is another important input. There's also thermal imaging that can be used these days with good thermal cameras. Deep learning, machine learning program purely can use architectures like CNN. Emotions can be detected using deep CNN, Alexnet, VGG60, and there's many more architectures. The more and more time passes, there's always a new library coming in with a better hardware, with better GPUs. We are able to train our models like really, really well. So it becomes very important for us to identify someone suspicious, someone nervous, maybe they're up to something. If there is a cue from our program that can detect a person for being suspicious, the security personnel can go talk to the person, pull that person aside, check the bags, look for any online transactions using NLP and other mechanisms in the past few days. Any abnormal activity, online activity, any abnormal travel, what's in their bag, what is the destination. A lot of things can be figured out. So that becomes a very important aspect with emotion detection. Now let's take a look at the next item also in fighting terrorism. Apart from the face detection, emotion detection, we also have situations like unattended baggages, right? So many of the blasts, many of the incidents, many of the threats that has happened, most of the times there is some unidentified suitcase or a bag somewhere lying there and the person had left it a few hours ago and scooted off, right? So many of these situations with abandoned bags can be easily detected. Now, in fact, it is already implemented in many airports. Major airports already have baggage detection, unattended bags. If you look at the side on the screen, there is a person walking away from the baggage, and within a few seconds, within a few meters of moving away from the bag, in real time, in live, it detects that there is an unattended bag. This person is moving away from the bag, and it actually brings up a kind of a message or an alarm on the person that this person is moving away and it's an unattended bag, right? So how do we do that? We can use deep learning with CNN, but CNN just detects a face or an image, right? So that's where things like LSTM, long short-term memory, comes into picture, which starts remembering every single frame of where it was 2 frames before and where the person is 2 frames after. So in real time, the person walking away, as you saw, could be a very important aspect. Now, apart from unattended baggage, facial emotion recognition, we should also look at discrimination as a problem. How do we approach solving the problem of discrimination? Let's take a look at that. Again, a lot of theories or the fundamentals behind it is similar in terms of the architecture of AI and ML, but the approach is slightly different. So, what is discrimination? People being treated differently based on their age, based on their gender, based on their race or ethnicity, caste, state, color, sex, religion, any of those, right? So, people can be treated differently by the hospitality crew or the ground crew or in hotels, in airports, and many other places. So we want to aim at living in an equitable world, and to do that, how AI can come to the rescue, or how we can take help from AI. Right? So one of the idea is to detect behaviors towards people by the hospitality industry people, like disgust and loathing. Could you please? Yeah. So there is a disgust and loathing type of scenario, and then there could be problems where air hostess or a ground crew or a security or a hospitality personnel could be smiling very nicely at a person from a specific race or a gender, but giving a fake smile because it's they are expected to smile. So a fake smile is something that can be also detected easily by training the model. Because when you really smile, right, there is it's natural. Your muscles on the face are moving, and the coming back or the contraction is going to take time. But if it is a fake smile, the muscles will not move so slow. It would be really quick. The eyes will not contract. It's all straightforward behavioral psychology, right? And then there is multiple repetitive items happening like this. It can get into reviews by the supervisors, and then they could see if there has been any discriminative actions. So let's take a look at how various emotions are used in discrimination. I'm going to play a video and take a look at how each of these emotions, right, can itself is data. To train a model to detect emotions, you would need a lot of data. Like you need hundreds and thousands of videos of smiling and disgust and loathing and even fake emotions. The reason being, not everybody smiles the same way. A person from one region could smile differently, and a person from another region could be smiling or showing his anger face in a very different way. Again, people from different races and genders and others can also have a very different way of dealing with it. So let's look at the approach for a discrimination approach of how it can be handled. So while we talk about emotion detection, there is an issue. There is an issue of privacy. Why would people be comfortable that airport is start recording what their movements are, identifying somebody? That could hit the issue of legal standpoints and privacy issues. So one very interesting concept that has come is subject independent emotion detection. What that means is you would never really identify or you would store any kind of a PII or even recognize a person. If unless they are on the wanted list, it's a match. That's a different algorithm. But if you're looking at smile, anger, fake smile, disgust, loathing, any of these emotions, it could be as straightforward as just training the model only for the part of the face that's required for the smile. So, which means you're not actually recognizing the person, you're only detecting the emotion. So, detecting different emotions, and if there has been a repetitive emotion, for example, there is a hospitality industry person who's greeting a customer with a good smile, greeting with a smile, and then there's a person with a older age walking towards the hospitality personnel, and there is no greeting. That's discrimination right there, right? And we saw the video that Jerry was talking about where a passenger was dragged out by the people from the airport aircraft, and they threw him out. It was a big news. Everybody knows that. And this is all something that we know, but there's many more that is untold. There's many things like a fake smile, right? I mean, how would you handle the fake smile? So if a person is continuously doing fake smile to a certain set of people, that is where we can find out that there is a discrimination against a specific race or specific ethnicity or specific gender or a specific color. So that would be one of the ideas of using subject independent emotion detection. In the next one, uh, so we looked at various aspects of facial
నేను
emotion
చూసుకుంటాను
recognition.
లైవ్ పెట్టినా
So when it comes to discrimination, we are looking at disgust and loathing,
నేను లైవ్ వాళ్ళు
fake
మాట్లాడుతున్నారు
smiles,
మా నేను లైవ్
and
చూసుకుంటానా
other
యూట్యూబ్ లైవ్ నేనే
negative
పెట్టుకోండి ఇప్పుడు
facial features
నేనే అది
towards
చేస్తాను
the
లైవ్
customers. And then when it comes to terrorism detection, we looked at nervousness, body language, and the fear, suspicion, fidgeting. All those aspects come into picture. So there are many architectures, like I was talking about. Alexnet is very powerful. It has
18
a
మెంబర్స్
lot of
చూస్తున్నారు
features, lot of
లైవ్
inputs, 6.5 million or 650 parameters and 6.5 million overall parameters. Deep CNN,
ఏమి
DLIB, and many more are implemented using facial emotion recognition. So we'll go to the next. So at this point, Jerry talked about earlier about the problem statement, and I covered some of the areas of what are the different approaches, what should be the methodology or the process to approach towards this using AI and ML. I would now invite Mr. Love Deshpande, who's our Director for Technology, to dive deep into the technical implementation. How does the aspects of CNN or how do we bring in LSTM, autoencoders? What are all these things? How are they playing into the field? So I'd like to invite Love Deshpande, who's one of our technology champions. Love, could you please take over the next steps?
Thank you so much, Praveen, for that. Thank you. So yeah, the biggest challenge of deep learning is how do we use the resources which are there in the deep learning to a great use of us and make it easier for us to solve the problem statement. So these are some of the topics which we
ఏం
will
చేస్తున్నావు
cover
నువ్వు
when it comes to the solution approach
ఏంది
we are providing for the
కాదా
terrorism detection and
చెప్పు
anti-discrimination. One is how do we use computer vision to solve this problem. Second is emotion detection, which is actually a base model, base package, one of the most critical parts of both of our packages, terrorism detection and anti-discrimination, then object detection, and then crowd anomaly behavior detection. So yeah, these are some of the most famous and most used architectures which are used for face detection. CNNs can be used in different way. CNNs are basically convolutional neural networks which help you understand, get information from an image and then use it for a purpose we are trying to use it for. The advantage of using some of the predefined architecture is the depth of the architecture, the context of the architecture, the training data on which it is trained will always help us to get some insights which have already been trained on. So that is called as transfer learning. So probably we use transfer learning in a lot of computer vision applications also. To start off with MTCNNs, there are hair cascade weights, there's FaceNet, DLib, OpenCV, and these are many more. There are many more different approaches, architectures which can be used to identify a face. So going on to the next part, which is MTCNN. Yeah. So roughly speaking about MTCNN, as it is seen in the figure, it has three different convolutional neural networks which are stacked together. First is called as PNet, second is called as RNet, and third is called as QNet. The primary idea is to split the process of face detection into some elements, into some subcategories, which will help us identify it properly, accurately, and precisely. First step is PNet, which is called precision net. What it basically does is it will generate some feature maps out of the images which are formed. There are some basic elements which, when it comes to a CNN, either a CNN converts an image into a matrix and stores it as a data, or it converts it into a single 1D vector and then generates some probability values. So the first part of the model, which is PNet, will not do the probability part, it will not predict something, it will not give information. It is an intermediate part which stores some data in certain form, and then that can be used to train further. The basic idea is when we are trying to train a face, it's very difficult to get information of the face directly. So how do we identify a face? We try to locate where are the eyes, where is the nose, where is the mouth, where is the outer part of the jawline and stuff. So those informations are stored in the first part of the combined stacked architecture. Second is RNet, which itself, what it does is now whatever feature points, feature maps which the CNN has generated, we have to extract data points out of that. When in the first architecture, it gives coordinate box of an eye, of a nose, of a mouth, but how do we specify it and correctly position it with respect to some XY coordinates? And that is what a computer will eventually understand, which will also overcome the problem of overlapping and stuff which happens in the first architecture. So basically second architecture will filter all the impurities and create more clear embeddings of the face. Third architecture is just a fine-tune architecture which has eyes, which has nose, which has mouth. All the features are captured. Now the challenge is how accurately are we using it? How accurately are we segregating it from the background image? So after the third architecture, you have a box saying this is the face located in an image, this is the position of eye, this is the position of nose, and this is the position of mouth. Specifically, we focus on these features because these are something which define the context of a human face. So we'll just see how we have used this to build our emotion detection model. So yes, the output is clearly seen. As the name also says, it generates 7 classes of emotions. It will show you neutral, anger, disgust, fear, happiness, sadness, and surprise. To start off with, how does a model get trained on this? How do we as humans understand emotions? And why I am referring to it in this way is neural networks is exactly a copy of how human nervous system, human mind works. So that is how we can understand it better. How do we understand certain emotions? If a person is smiling, then there is a particular way his facial features change. His eyes may shrink, he may show his teeth, the part on the jaw changes a bit of its shape. You can see the lips moving a bit. So all these transitions, all these alterations in the actual default face are captured. So this is how an actual convolutional neural network captures the emotion and stores the augmented data of any emotion. These 7 categories are the basic categories of emotions, but we always do not use them as it is. Say, for example, as Praveen was referring to, we have to detect a nervous emotion. Nervousness is something which is very specific to an individual. You cannot directly look at his face and instantly say that he is nervous. So there are some trends in emotion which define nervousness. Say, for example, a nervous person can be frightened. A nervous person can be a bit sad. He can be a bit angry also. So it's combination of neutral, anger, disgust, fear, and sad, with each emotion not exceeding a certain specific value. When nervousness goes about a certain value, you are strong, your model strongly says that okay, this is a nervous emotion. But if it is there in a specific limit, in a specific threshold, and it adds to other companions of emotions like anger or sometimes fear or sometimes sadness, then the combination can be detected as a nervousness emotion. So yeah. Okay. Alexnet is an architecture which is a CNN based architecture we used for the training of emotion detection model. We did try different versions of transfer learning methods like AlexNet, VGG16, there's Inception, there are many more FaceNet and stuff. AlexNet gave the best results because as it is visible, it is a very deep neural network which starts off with a basic 3-dimensional image, then it converts and starts extracting the information out of it. And later on, there are some layers like max pooling. Max pooling is basically going to average the information of every grid which is generated in an image. And then this information gets on saturated, and you end up having a single vector which says the same thing the whole image used to say earlier. So it's a way by which you extract information from an image and then classify or use it as we want it. So the overall architecture of AlexNet looks like this. There are max pooling layers adjacent. And one specific thing which happens in any CNN model is if you look at the change in shape of the cuboid, it decreases its height and width, but increases its Z dimension. Basically, what it is trying to do is it is reducing the image, but not losing information. That is how you increase the computational power also when you are analyzing and classifying and building a model. So yeah, that is roughly how an Alexnet works. To go to the parameters and how they are defined, what number of parameters are used. Okay, this is overall structure of what all things go in an Alexnet architecture. There are roughly 6.5 million parameters which go around in training. When I say parameters, you can assume that these are individual neural blocks which contribute in storing some sort of information and then predicting and generating some other sort of interpretation of the information. So this is how an overall Alexnet architecture works. So next part will be how do we use and implement the object detection model. And for object detection model to work better, there are some prerequisite things which also work. Say, for example, we have to train a face recognition model. Now, we cannot directly pass a face of an image of a person and train a face recognition model because it will waste 50-60% of its computational power just identifying what I have to learn. When I say I am a model. So that is where these architectures like DLib help you in filtering the initial part of the training. As seen in the figure, it gives you 68 feature points on your face. And if we try to understand how human brain identifies a face, this is exactly how it does. You see the eyes of the person, the jawline of the person, and the interrelated distance, which we in ML terms call as embedding. Embedding is basically a distance between every point out of the 68 points with every other point, and you get a 68 by 68 matrix, which says an information about that person. So that is how we have trained or we train the face recognition model. This can also be an input to emotion detection model.
मेरी गलती है क्या जो करना ही नहीं ये मेरा
So we'll just see how an object detection model works. Next slide, PD. So yeah, object detection is a bit different from image classification. I would say it is image classification and something more. When I say something more, I just do not identify a cat in a picture or dog in a picture. I have to specifically say where that cat or dog is. Now, how does this happen is there are different ways. There is something called as semantic segmentation. Semantic is basically understanding meaning of the image. When we take the process of semantic segmentation, it classifies the pixel values into what class it belongs to and what is background. And then the difference of classification will give you where is exactly the object located. That is roughly what an semantic segmentation does. And then this is how object detection works, where it detects. Recognition is combination of detection plus classification, wherein you not only spot where that object is, but also identify what that object is. So eventually, every object detection model is a recognition model because it does not help only identifying a certain object in a frame. You have to also understand what that object is. So we'll look at some of the architectures which are used for object detection, like YOLO and RCN. So these two are primarily the most famous ways of training an object detection model. RCNN is called region-based convolutional neural networks. It has its other versions like faster RCNN and stuff with some changes to the base model. How this works is it will take your image, split that into grids. For every grid, say it is identifying a dog. It will see if there is a dog in individual grid. If it is not, it will move further. So there is a sliding window which moves around the whole image. And at the end of the day, wherever the chances of the prediction model predicting probabilities is high, that is the location where it can say that, okay, this is a dog. YOLO is a bit different, works a bit differently, slightly differently, because the primary objective of YOLO is to pass the image at once. It will not work for every grid separately. It will convert the image into grid, and at a go in one neural network, it will pass the image. And YOLO will give you in one trial run where exactly the image is, the object is located in an image. So that is the only difference. RCNN will keep on predicting in some parts of the images, split it, understand it, and predict it. YOLO will at a go understand the whole image and then predict. We have advantages and disadvantages of both. So YOLO is a bit faster, as I said, and RCNN comparatively is very slow, but yeah, next slide. our CNN is very slow, but the reason why we have used YOLO in most of the models is the accuracy difference may be not more than 2% or maximum 3%, but the latency difference is very large. You cannot build a FCNN model classifying 1,000 different classes of objects. YOLO does it very well and very fast. So that is an edge of YOLO. The disadvantage where YOLO might suffer a bit is, say we are training X-ray image where we are trying to figure out some of the patterns in an MRI or X-ray where there is more detail in the object. That is where YOLO will not work well. That is where faster RCNN or RCNN will work well, because you cannot predict the whole image at a go. You have to analyze every small element of that image. But because the applications, as you saw, where we are using it is like unattended baggage, we have head count detection and stuff, wherein we don't identify such small subjects or such small objects. That is why we have preferred using YOLO over FCNN. Next part is anomaly behavior detection, crowd anomalous behavior detection. So here, interestingly, we have used a very, I won't say new concept, but this is a combination of two major architectures used in deep learning. One is LSTM and one is convolutional neural network. Convolutional neural network is preferably used for images, not always, but what it does is it extracts information. LSTM is a memory unit. It basically is an extension of time series kind of algorithm wherein it stores what the information is over a period of time. We have combined both these things together to predict some anomalous behavior. The way this works is, say, for first 5 minutes, I am imagining a situation in an airport where the crowd is just randomly moving. There is very subtle movement. There is just random movement of the people. What does this model do is it will take those frames, train for those frames and predict for next 5 frames. Because there was some normal movement, next 5 frames predicted will also have normal movements. But what happens is if there is some sudden change in the behavior of the crowd, suddenly people start running here and there, or there is something wrong happening. That is the time where the actual frame is showing something else and the predicted frame is showing something else. So this will help us understand that there is something anomalous behavior happening in crowd. Now, this is one example of a crowd anomalous behavior. This can be trained anywhere and everywhere. So that is how this works. The diagram on the right side is a diagram of Convo LSTM combination. The only change is, along with the LSTM model, which has some parameters like a forget gate, which lets you forget the information which you don't want to take forward. Then it has memory storage units. Then it has some activation functions and stuff. The only thing which changes is you have an image input. For a regular LSTM model, you just have a time series or a single vector which is passed in. Here it is a two-dimensional image input, and that is how you combine your convolutional and LSTM layer. So we'll just have a look at why did we use an autoencoder and how did it help us. So from the figure, it's clear. Basically, an autoencoder will encode information, convert an image into some sort, not always image, any other form, but in the context we have used it, it was an image data. It will convert it into a base root of by which it is generated, and then it will regenerate the same image again with some changes in it. Why do we do this is, as I mentioned, we are storing information for say 10 frames, 20 frames and generating for next 25 frames. So that generation for next 5 frames happens in the second part of the encoder, which is second part of the autoencoder, which is decoder, and collecting and understanding or training of the data happens in the first part, which is your encoder part. So yeah, this is how roughly an autoencoder works, where you generate the same data and understand what are the changes in a normal behavior and an anomalous behavior. So I would just request now Praveen to just give a recap on what all things we covered, what are topics we covered.
Yeah, sure. Thank you so much, Love. It was very informative and in-depth. Very good analysis of the implementations. So first of all, thanking Jerry and Love, I would also want to do a quick recap on what all we've been discussing. We are talking about racism and terrorism detection using AI artificial intelligence, machine learning, deep learning, and other techniques, right? So how do we go about it? There's a lot we can do. There's a lot of stuff that we can do about it. The first and foremost thing we talked about was computer vision, where we could do face detection, face recognition, people from the wanted list, or people walking into unauthorized access places, and all. So how did we do that, or how do we achieve that? Is there are many architectures. The fastest one, or some of the fastest ones, were like MTCNN, and we could also use the interesting DLEP, which has very interesting the 68 point, like how Love explained. So that's one way to do computer vision. Then we also looked at emotion detection. Emotion detection, which is about nervousness detection and stress and fear and the emotions that give off about a person who is suspicious. That is another area that we looked at. We have architectures like Alexnet and VGG16. We also looked at emotion detection for discrimination, which is about how hospitality personnel could differentiate between people from different race or gender, fake smiles, disgust, loathing, and some inappropriate emotions shown towards the customers, which would be negative. And then we also looked at how object detection, which plays a very important role in curbing terrorism, and the person who's probably carrying a ceramic gun, who could go undetected by metal detectors, or somebody opening up a firearm in public, dangerous items, flagged items, real-time detection. All that was quite important. We talked about it, and architecture to do that was the two families that Love talked about, RCNN and YOLO. You only look once, and the region-based CNNs. And then we also looked at, while talking about the computer vision and all, we talked about NLP. We talked about how online terrorism and stuff that Jerry was talking about can be, NLP can be applied in detecting texts and calls and other stuff. We also talked a little bit about anomalous behaviors of people, suspicious situations, like a person standing out of the crowd. Suddenly, a lot of people are running away from a specific point. All these could be good indicators of anomalous situations. And for that, we looked at situations like convolutional LSTMs, DB-LSTMs, where it's a combination of neural network and a memory combined together as an architecture to work on that. So that was a bit of a recap on the overall presentation today. We would like to talk about the next step. I'd like to ask Jerry. Before Jerry coming in, I'd also talk about challenges. While we would be very optimistic to implement this, it's not an easy piece of cake, right? I mean, there are a lot of challenges. First of all, how do you collect so much of data? While I was talking about different races, different ethnicity, different regions and countries and areas of people, everybody has a different kind of a smile, different emotions. We need to collect the data and train the data. It is possible. It's not impossible, but that is a bit of a challenge. But you would get that information. And then just detecting nervousness is not alone good enough, right? I mean, it's a lot more than that about the body language, because somebody could be naturally nervous just because you're waiting in an airport, right? I'm waiting for half an hour. I'm going to be just looking to my left or right, or I would be just looking up or down. That could also be misinterpreted as a nervousness. So you need to add multiple things and build a terrorism detection score, like we talked about in one of the slides in the past. You look at nervousness, you look at how their behavior is, what's the body language, everything combined starts building up a terrorism detection score. Same thing for discrimination, whether a person is not smiling for a reason, or has it been a repetitive issue. Right? So again, we run into situations about depth estimations, because what happens in real life is 3D versus what happens captures in a camera is 2D, right? So the depth could be a challenge. So if a person starts moving away from a bag or a baggage, or the distance could be different in real life versus what it is on the camera, right? So there are some techniques to have some objects references inside the places, so that we could always get a relative space and always get the exact image. The most important one, the final one, has been on the privacy information. Collecting private information or personally identifiable information, PII, is a big challenge in most of the countries. And that is something we need to be worried about. But again, by applying techniques like subject independent emotion detection, we could always ensure that none of the personal information are identified. When it comes to the crew who are operating, they would have their contract signed with the airlines or the airports or the hospitality industry establishments. So they would be okay to get them recognized, because you would like to get your attendance done through a face detection. That's very common these days. You don't want to swipe your card. You don't want to put your finger. You just walk towards the door and it starts opening up. That's happening already everywhere, right? So that's a highlight on some of the challenges. And coming to the next steps, I would like to invite Jerry to talk about what we have in mind. We would like to offer you something which is a POC. So Jerry, could you please come in and talk about it? Thank you very
A
much.
little bit. Sorry. Yeah, absolutely. Sorry, I cut out a little bit. So, hello everybody. So 6 week. To conclude, thank you everybody for coming. I know you guys are all really tired right now, but yes, like we hope that you guys had a good time. We had a good time talking about this, and we hope to have a 6 week POC, and in which we have a proof of concept, no obligation, and we have provided a lot of different use cases with different data scientists and different opportunities like that. So if you're interested, please follow a link and drop us a message, and I'll hand it on to Praveen for more information now.
Yes, thank you, Jerry. So yes, the 6 weeks proof of concept is something which is very unique that we're doing. A lot of companies, a lot of our prospects and clients are reaching out to us, like in the UK, in Germany, in Canada, in the United States. People are asking us, what is the 6 weeks POC all about? Definitely wanted to talk about this. So the 6 weeks POC is something that if you have a use case, if you have a requirement that you want to try it out, you can test it out, you could reach out to Zummit. This is at no obligation. There is no charge. There is no fee. We will be putting some of our data scientists, a couple of them, three of them. They would work on the use case if it is interesting. If we feel like this is a good use case for us to work with, then we would definitely want to take it up. It could be something related to emotion detection, face detection, reinforcement learning, NLP, self-driving cars, autonomous driving. We were already doing some of those with some of our clients in, again, like I said, in the different parts of Europe, UK and Germany and other places. So we have been working on a lot of use cases already. We have working live code of 22 different use cases of different projects. And then we also are building another 45 use cases pretty soon in the next couple of months. We are aiming to build up at least 200 different use cases in the coming 6 to 8 months. So yeah, it would be all very, very interesting. It's a generative adversarial networks, fashion GAN, CGAN, and we are working on different aspects of CNN like DLib and YOLO and Pure CNN, Alexnet, and many other things. So we would encourage you guys to reach out to Zummit InfoLabs, send a mail to info@zummitlabs.com, or you could reach out to us on LinkedIn, send us a message, or drop a mail, go to our website, go to the contact, or whatever means that you want, you could go ahead. So with that, I would like to end the presentation, and I'll open it up if anybody has questions. I know that some of the folks were asking questions on the YouTube. This whole video is also being streamed on YouTube Live. So there are people who are asking questions on the YouTube, and some of them were like, what's the difference between computer vision and image processing? I'll probably take that up. So image processing is just processing images, right? Just purely images. But computer vision is slightly bigger, wherein it could be any type of a visual inputs. That could be images and videos from CCTV cameras or pre-recorded videos, real time, live, or uploading images, uploading videos, doing a lot of analysis on that. So that's one of the primary difference. And I did not understand the question about Morse code. I know somebody asked, can we detect Morse code? I mean, we can detect anything if that is given as an input and if you know what is the output. The way neural networks or machine learning or deep learning works is you provide a lot of input with the input data, and then you also provide the output, what was the observed value there, and then the program can be trained. And once the program becomes intelligent enough to understand what was the logic behind the outcome, then you feed the data, it predicts the value, right? And personally, to me, I prefer deep learning over machine learning because deep learning is very easy. It does not have any complex statistical inference of any kind. It's just feed the data, build a network, train the model, keep improving, and then you get amazing results. Right? So, but again, there are a lot of use cases that request machine learning, a lot of them requiring deep learning and GAN and many more. Right? So, thank you. I'm gonna leave this open for people to ask questions. And Love, feel free to add if you want to add anything, or if there's any. Love, you can come on the call if you want to.
Sure, sure.
Any questions?
There's one question in the log.
Oh, here?
Yeah, in the chat box.
Okay. Yeah. Okay. Somebody answered the question. Yeah. Thank you. Prashant from audience has answered the question about the Morse code. Yeah. Okay. Oh, so probably the question was like, from an image, can you detect the Morse codes? Probably, if that's the question, then we could use OCR. But I don't know if the question was more about, if I give the input as Morse code, would you be able to tell me what is it? Right? Was it dot and dash is an A, right? I mean, there's a SOS signal. So if that is the input, could the program, like what if somebody is stuck somewhere and made a SOS signal on the sand of a beach, like a castaway, right? And if a helicopter is running ashore, and if it can read that Morse code signal, and I don't know, maybe I'm just thinking loud here. Yeah, Love.
Yes,
So,
Praveen. Sorry, I just was reading one question.
okay. All right. So if there's no other questions, probably we'll try to answer that on YouTube. I think people are chatting on YouTube also. Thank you, everyone, for being here for the presentation. And thank you, Jerry, and thank you, Love, for wonderful topics from your end.
Thank you, Praveen. Thank you, Jerry.
Yeah, and also many thanks to Prahars and Katie and Nachiket and Sonika and the whole team in the back end who's been working on building this presentation. This will be made public on YouTube, and it'll be shared on many channels like LinkedIn and other places. So yeah, thank you everyone. Have a wonderful day, afternoon, and night, or wherever you have logged it from. Thanks. Bye bye.
Thank you, guys. Bye.